I first met Miles in 2006 when I was an intern at Google. Well, he was also an intern at Google. And the two of us went back and forth on various thoughts on, it seems like Google gets to have all the fun playing with really good data sets. Maybe we could do something with smaller amounts of machinery if we were more clever with our algorithms. And so he went off and continued to work with student David Talbot, who then ended up at Google, on very clever ways of putting language models in small bit sort of structures, and going from more MT applications from there to streaming machine translation to then streaming social media, which has become one of the major things we're looking at lately. Both the PC for the social media tracks within ACL and MLP lately, and then doing a lot of really great work, as we're going to talk about today.
Okay, thank you. Right, okay, so a few things. So, firstly, thank you for having me here at vast expense from upstairs. It was a long journey to get here. The second thing is that I don't speak very loudly, and this is not a microphone here, right? So I will try to project and this kind of stuff. But if I start speaking quietly like this, right, just pardon me. The other thing is that this particular talk, I've given this talk many times actually, and I normally tailor it to the audience, as you'll discover. But this particular talk is aimed at a fairly general audience. Now, behind the results I'll be talking about, there are papers, right? So if you want the gory details, then either talk to me after or read the papers, right? So this is primarily designed to be accessible to basically students and stuff like this, and people who are not specialists in IR and the like. Okay, good.
All talks should be like that.
Yes, exactly. Okay, so I'm going to keep going backwards and forwards from here so I can actually project and this kind of stuff. Okay, so what I'm going to be talking about is basically what's occupied my time mainly since 2009. And like all work, it's not just me. Sort of most of the credit goes to basically my students and people I work with. So the top line are grad students of various kinds, and Victor is an IR person originally from UMass. And the people below are full-on information retrieval people from Glasgow. Now, one new thing here is that if you know anything about how sort of Scottish academic politics works, you'll never see Glasgow and Edinburgh on the same slide ever, right? So this is this is groundbreaking stuff. Yeah. So people like this kind of thing. Okay. Yeah. Okay. So what is the task? So I like modest tasks. So tasks that are very easy to do. And the task which we set ourselves was trying to find all breaking news that occurs in the world as quickly as possible, right? So as I say, it's very modest. You can imagine doing this in an afternoon, right? Now, the problem here is that because we're listening to Twitter, as should become clear, the vast majority of the posts you encounter are absolute rubbish and or low quality. So you need to sort of have mechanisms to deal with filtering out the garbage. And the other aspect is, as I said, this sort of heavy focus upon making it efficient. So here is okay. So the main results in this talk. There are 3 sections to this talk. The first one describes the machinery to get it working, and so this is fairly rare for an academic talk. So I'll be presenting results which process more than 250 million data points per day. Right? So you often see that kind of thing. So that's one aspect. The other aspect are a series of quality improvements trying to filter out garbage and promote good stuff. And the final part is it's a slight change of emphasis, and is looking at the relationship between news in Newswire versus breaking news in social media, and trying to sort of get behind some of the hype that you see in this world. Okay. So I've been working with Twitter for quite a long time now. It hasn't been going for very long, right? For a number of years. And when I first started talking about Twitter and I had to explain what it was, right? But I think nowadays I don't need to bother with this kind of thing. So I can just sort of present some of the statistics that are relevant to this particular task. So the first one is that there's a very small amount of signal to all this noise, right? And this is compounded by the fact that people would insist on using languages other than English to talk about, and it's a dreadful fact, right? So Twitter is increasingly multilingual. So at one stage I did some language ID over Twitter, and at that stage about 65% give or take were in English. I think it's probably lower by now. And here's a quick question. So what do you think the second most popular language other than English is on Twitter?
Chinese, that's my bandwidth.
Okay, we won't talk about Chinese. There's not Chinese. No? Okay, so it's Brazilian Portuguese. Right, so people in Brazil love Twitter. Okay, so there are lots of people using it and lots of posts per day. Now, one of the important properties, at least for this particular talk, is that at peak, Twitter produces 140,000 posts per second. Right. So on average, it's more like 4K per second, or perhaps a bit more. But at peak, it's 140,000 posts per second. And we wish to be able to do our problem solving at that rate. Right, so that's a very important fact here. Okay, so here are a few examples of good tweets. So Twitter is used for all sorts of things and by all sorts of people. So I gathered these examples when the Icelandic volcano was doing its stuff. So in the first one, you see a news entity using it, posting it. And then in this particular tweet, you see someone commenting on that particular post. And the second and the third ones represent people who are trapped by the Icelandic volcano. Okay, so you see, so this is fairly nice. So the language looks okay. It's fairly structured. You see these sort of semi-jokey sort of hashtags or hashtags, this kind of thing going on. Right? So that's okay. Unfortunately, most things don't look like this at all.
Can you just explain to me what the first one is?
Yeah.
It looks like the
Okay. So you're now a victim of me thinking everyone's understood what Twitter is. Okay. So what's happened to the RT means that someone has, it's called retweeting in Twitter, so someone has reposted the original post. The @Channel 4 News, that's the author, which in this case is an entity, it's not a person, it's an organisation. So the original author has posted Scottish airspace, blah, 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 right? The hashtag, that's some sort of, that's a free-form comment that someone has made, which is somehow trying to help people find related posts. So there's a convention on Twitter. So after the hash, I can't say it. After the hashtag, right. I'm getting confused here. Yeah. After the, I won't look at the screen. I'll be fine. After the hashtag, there's a comment, right? So you see, so you've got the original post, and then someone else has commented on the thing. Okay. Right, so these are nice examples. Unfortunately, reality looks like this. Right. So as I said, it's very multilingual. The bane of my life is in the top one, Justin Bieber. So if you do any serious work with Twitter, you will encounter Mr. Bieber and his followers. Yes.
So are these the 95% of garbage? And by garbage, do you mean that they're not related to breaking news?
Yes.
Okay.
And the rest. And the rest, right? Anything. So it's hard to.
So it's really true that 5% of tweets are related to breaking news?
Ish. Okay. Yeah. So so stuff like this, right? There is content, but the problem is dealing with this stuff. Okay. So you see, it just goes on and on and on. And if you look at Twitter for long enough, you lose the will to live, especially with Justin Bieber. Yeah, okay. Now, as I said, there are sort of actual content-bearing posts that are made. So a number of years ago, the CEO of Sun announced his resignation first on Twitter in this manner. So this was some attempt to be clever, using this little haiku thing. You also get this kind of stuff. So people sort of tweeting in the sort of heat of the moment. There was actually a fairly recent, so this was a few years back, there was a fairly recent account by some jihadists in Somalia who were tweeting whilst they were attacking. That account was sort of pulled fairly quickly, right? But all sorts of people sort of getting into the game here. Okay, stuff like this.
So you would consider this to be breaking news?
Not in this case. Not in this case. Right. So these are just sort of examples of content. Right. We'll get on to the news later. Okay. Now, what about Twitter for breaking news? Okay. So many people sort of think that Twitter is a good source of breaking news. So one aspect is this sort of immediacy. So there's a real-time aspect. So people are sort of embedded. You're attacking some. Whatever you're attacking, the planes crashed, the earthquake's happening, all this kind of stuff, right? So there's this sort of real-time aspect to it. Another sort of important point is this notion of citizen journalism. So most of the stuff that you read is professionally created and it's filtered, right? So The Guardian, CNN, Reuters, and so on and so forth, they act as a gatekeeper between what's actually happening in the world and stuff which is delivered to you. Now, this obviously, there are many sort of aspects of this. So, for example, there's things like these people filter out stuff which is believable, some stuff which is false, stuff they think is going to sell, and so on and so forth, right? Another sort of viewpoint on journalism is this notion of citizen journalism, where you're trying to sort of make it much closer to the people who produce the news. So Twitter is seen as being a way for people to propagate citizen journalism. So in particular, things like earthquakes, all sorts of disasters like forest fires and this kind of thing. There's this canonical example of a plane crash, which I'll come to later. In London a few years ago, we had these excellent riots. So people were tweeting from all sorts of angles for these sort of riots. Gossip, and it just goes on and on, right? Now, even if you're not interested in citizen journalism, you just care about newswire, Twitter is an excellent way to aggregate news. Now, it turns out that to try to be on top of all of the breaking news in the world, and if you just care about newswire, this means visiting lots and lots and lots of obscure websites. Right? Now, I'll return to this point later, but it turns out that many, and perhaps most, news entities repost their content on Twitter. So that means that Twitter acts as an aggregator of newswire out there. So that's good for that as well. And the final point is that Twitter also acts as a way for people to comment on news and get reactions and sentiment and so on. Okay, so I made an attempt. I tried to say Baltimore is famous, right, for not necessarily the good reasons, right? So I ran our event detection stuff over a number of years, and I didn't find anything to do with Baltimore directly in 2011 or 12, but I did beginning of this year, right? So most of the stories were sports-related stories. I don't understand what's going on here at all. But Baltimore is in the news in this sort of way. So you've got the person from The Wire sort of dropping dead, some sportsy thing, and some killer. Okay. Yeah. I also tried to do this for I was in Penn a few weeks ago, and I tried to do this in Penn. I couldn't find any sort of interesting sort of stories of Penn at all. So Baltimore has an edge in some respect. Okay, so Another sort of important sort of use case for event detection is in finance. A number of months back, there was an example of the AP. They had their account was hijacked, and people posted a fake tweet. Right, so the event was actually, in this case, it was a false event, and this caused the Dow Jones to plummet 1%. Right. So you can see that if you could spot this event, you could potentially make a lot of money, right?
If you could create this event.
Even no. You do both, right? You create the thing and spot it. Yeah. And below it is for this particular event what our event detection stuff found, right? So in this case, if I remember correctly, yeah, it's some kind of comments on this sort of thing, right? So the finance people are extremely interested in event detection in Twitter. One of the reasons for this is what people care about is seeing news before it's reported on Bloomberg and Reuters and the like. And this is potentially a way to do it. The other aspect, of course, is trying to find news which is never reported on Bloomberg and Reuters, which might have financial impact. Okay. So something which, I've had and have some grants that are funded by the security agencies in the UK, and people are very interested in this kind of stuff. So here are a number of events which we have automatically discovered. I picked up some UK ones, I think. Yeah. Okay. So the Derby one is quite interesting, right? So this one was taken during these riots, which weren't just in London, they were across the country. And so you can see here the police are trying to sort of talk to people out there and so on. You also get events, things like people trying to do naming and shaming on vehicle theft and stuff like this. So it just goes on and on. Okay, so that was the kind of the backdrop. Now on to sort of the actual talk itself. So as I said, there are 3 parts to this talk. So I'll now talk about the how to solve this task and at scale. Okay, so the actual task we're looking at is not new, and we didn't invent it. So this was actually popularized as part of the TDT program, which was around 2000, give or take. And at that point, people were focusing upon Newswire, Newswire of low volume, right? So instead of seeing 140,000 posts per second, you might see in the low thousands per day at best. So for the TDT track, the data is at a lot lower volume, and also it's high quality. Right? So the difference is here is that we're dealing with everything, all sorts of garbage, and also the volume as well. Okay. So for the actual task itself, what we try to do is we try to spot some kind of event, and we're deliberately vague about what an event is. Roughly speaking, we consider an event to be some self-contained post that talks about something. Right, so we don't deal with, in this case, the situation where some event is partially described by, say, multiple posts. So once you've found the event, you try to report it as soon as you can, and you don't report follow-up posts as well. Okay. So you can see here why it's important to deal with the latency aspect, because the longer it takes you to process it, the less value the news has. Right, so there's a real premium on trying to make decision-making as quickly as possible. Okay, so this slide I'm going to start sort of glossing over details. So how do these things work? Well, okay, so a typical new event detection system, or first story detection, which is the same thing, typically works as follows. So each incoming post is converted into a vector, and each component in a vector would describe whether you see a word in that post or not. These terms are then weighted, which gives you a vector, like so. So, for example, you may have, that's completely made up. So you can imagine, like, say, hello, how are you? Becomes something like this. And because we're listening to a stream, we store all of these stories / vectors as we see them one by one. And every time we see a new post, a new incoming document, we need to decide whether this is new or not. And the standard way to detect novelty is to take this incoming post and basically compare it to all of the previously seen posts. So these are vectors, so it's lots and lots and lots of cosine angles, if you know about this kind of stuff. Okay, so we look at the incoming post, we find its nearest neighbor, and if its nearest neighbor is sufficiently far away, then this incoming post becomes a candidate new story. Right? So this means that the naive version of this is n squared. And remember those statistics which I gave about Twitter earlier on, 140,000 posts per second, right? All the time. Okay. So trying to do this naively is obviously impossible. Okay, so how might you make this efficient? Well, okay, so one strategy is to build a special hashing scheme which has the property that if two posts collide under the hashing scheme, then you believe that they are similar to each other. Right, so normally when you construct hashing schemes, you don't care about collisions at all, right? And collisions are a nuisance. But here, we actually want to engineer our hashing scheme to have this kind of property. And in particular, if this document and this document collides under the hashing scheme, then we can conclude that with high probability they are within some distance r to each other. Right. Now, for the perspective of this talk, hashing is a constant time operation. Right? So remember previously I mentioned that it takes n squared to do this sort of thing. Now we can do it in O1 time. And this is why this is efficient. Okay, so how can you construct this magical hashing scheme? So here is a very high quality diagram, which by the way, here's an aside. So Hopkins in particular has this sort of reputation for doing very, very, very glitzy presentations with things moving around and bubbles and this kind of stuff. So this is the anti-Hopkins talk, right? This is the extent of a glitzy presentation, right? Okay, so how might this work? Okay. So how might this work? Okay, so here we have 3 documents in this vector space, and intuitively the red document is a long way from the green one and the turquoise one, right? So if this red one came in, if the blue one came in, you'd hope you'd find the green one quickly and not the red one, right? So the way the hashing scheme works is that we take this space and just draw a line randomly down it, and depending on which side of the line you are, you get either a 1 or a 0. Right, so here, the green and the turquoise would get a 1, the red would get a 0, or vice versa. And we keep repeating this task, right? So the hash scheme, which decides whether 2 documents are similar to each other, actually has multiple little hashes, and each random line gives you a new bit. So here, for instance, we have P, Z, and Q. And H1 may give, say, 0, 1, 1, H2 or 0s, H3 or 1s. So the composite hash function is a concatenation of all these bits, right, like so. And to give you a feel of how fast this thing actually is, the literal hash function is there. Right, so we take our document, we randomly sample a vector, and just look at the sign. and that gives you the bit, right? So clearly this is extremely fast to do, right? And speed is important, as I'll show you later. Okay. Although, why do you think it's important to have multiple hash functions, not just one? No? Okay, so if you had, if you just had, say, this one here, if you just had one hash function, right, then it may be, for instance, almost all your documents are one side. So there's one bit, it's not going to give you much information. So really you want to be slicing this space up so that you have relatively small clusters of documents in each cell. Okay. So here are some results. So we took a system from UMass, which so this is on Newswire, so it's not on Twitter at this point, and we compared it to our constant time version. Both systems perform equivalently. The red one is the sad curve, because it's getting worse and worse and worse. Right. So this is an optimized indexing-based system. It's not crippled, right? So this was a serial system, and our system in blue has constant time, right? So it performs identically. Okay, so this sort of demonstrates that this hashing-based approach which I sketched is capable of doing the right thing. Okay, so this is one of my favourite slides because it's just the difference between the indexing-based system and the hashing thing is just day and night. Okay, you don't often see results that are this clear-cut.
When you say that performs similarly, what is that performance that you mentioned? That you find the correct nearest document?
Okay, so the way that FSD systems are evaluated in something called det curves and the like. So this produces the same det curve as that one, right?
Okay. So you're saying when it makes a mistake finding the closest story, that doesn't matter to the eventual evaluation?
No.
But out of curiosity, how often does it make a mistake? Since you can use this to do the comparison.
Yeah, so I don't know offhand that details. Okay.
Just like the other applications where the search error did make more.
Yes. I mean, so we've used LSH not just for this, so things like, so there's something called retrieval models, relevance models rather, in IR, and these things are extremely slow. So a relevance model in the IR world basically has a basic retrieval model, but it also does a form of query expansion, and this boosts the retrieval scores, but it's horrifically slow, right? So you can, for example, embed LSH into this and so on. It just goes on and on. There are lots and lots of applications of LSH to speed up. Okay, so basically LSH enables you to quickly find nearest neighbors, but remember we're dealing with many posts per second, right? So we also need to parallelize it across the documents. So we looked at something called Storm. So I'm sure that everyone here has heard of Hadoop. So Hadoop is a way to do large-scale data processing, but the problem is Hadoop has this batch nature to it, right? So which is useless as far as low latency event detection is concerned. Now, Storm, by contrast, you can think of it as a quote-unquote real-time form of Hadoop, and all of the computation lives in memory, right? So it doesn't touch disk at all. So that means it's extremely fast, and it has a very low latency. So it's a very good match for this particular task. Okay, so blah blah. That's what I just said. Okay, so here is a sort of impressionistic sketch of what a Storm topology might look like. So within Storm, basically you can think of the job is to construct a graph where the nodes in the graph represent some kind of computation, and the nodes communicate via remote procedure calls. So here we might listen to the stream of Twitter as it's coming in. We might have another one job which takes the raw posts and converts them to vectors. And then you have jobs which represent how the LSH tables work, and so on and so forth. Right? So, like so. Okay, so here are some. So we looked at some scaling experiments. So the task here was to do this event detection over 1 million tweets, looking for novelty, and each individual tweet is hashed, roughly speaking, 700 times. All right, so why is it 700? Well, we actually construct 13 hashes for one individual LSH table, but because LSH can make mistakes, the way that you drive down the error probability is to replicate it with multiple hash functions, and we do this 70 times. Right, so there's a lot of hashing going on. Okay, so what we're able to find is that using Storm we can get a linear scaling in terms of the number of machines. So if you throw more machines at it, it gets faster. And we estimate that we would need about 70 cores to process the full fire hose at line speed. Right, so that's pretty good. Okay, so one of our students is presenting this right now at this event.
The reason you don't do a big hash of 70 times 13 dimensions is so that you can parallelize it? Is that what's you could have just had a bigger number of bits.
You could. So do you want me to go into details of how this works?
No, just the motivation. Why
Okay.
you do
Okay, why?
70
Yeah. Because
ones rather than one bigger one?
Yeah, because okay. So LSH enables you to find the nearest neighbors to one document, right? But many of them all coming at once. So you need to parallelize it across all 70. Yeah. Okay.
You're saying that any one document will only get one hash function or two times?
No. Look. So if we just using LS8, this enables you to find nearest neighbors efficiently per post, right? But we see many of them coming in all at the same time. So basically, you want to parallelize across all of the things coming in at the same time. Okay. So at least as far as we're concerned, the efficiency sort of business for FSD is basically solved. Right. So that's why it goes. Now on to the quality improvements. Okay, so if you run an event detection system as I described over Twitter, you will discover that less than 1% of the events that you pluck out actually contain any content at all. And the reason for this is, well, here's some actual examples. Okay. So if you look at number 2, right? So a naive FSD system would think that number 2 looks like an event. Does anyone know why number 2 is thought of as being an event? Yeah. So remember the way that the thing works. We take the post and we try to see whether it looks different to all the other posts we've seen already, right? So if you have type, so we don't do any normalization here. We lowercase terms. We may stem them, but we don't do spelling corrections and stuff like this. So this I lovey my nephew hair sort of thing was seen as being new, right? But obviously it's not new. And just get, all sorts of strange things going on, right? Okay. Okay. So how might you? How might you sort of make things better? Well, I'm going to sort of describe 2 strategies. One of them, which exploits the way that Twitter works, is basically to see whether there's any follow-up evidence for something. And the second one, which is what the talk's about, is to see what's happening in the rest of the world. Sorry.
My question was about, so once you complete the hash function, then the proxy for the cosine is the Hamming distance.
Yes.
So, but the Hamming distance in any fixed number of bits can only be the total number of bits. So you only can have, say, 1,000 novel stories, right?
No.
The range of Hamming distance can be 0 to 1,000.
Okay, so what actually happens is you get multiple tweets with the same code. So you in effect get a list of tweets of the same thing, and within that set, we do an exhaustive search. So what the hashing is doing is taking the document space. Let's say it's just one hash function, right? You split it into two. So that means that immediately you don't need to consider the other half. You just consider the half that have the same code. Yeah, you can think of it as like that. Okay. Okay. So
13 bits, you split the
2 to 13.
You split into about 8,000 subsets of the documents.
Yeah. Well, okay. So some of these things are
They're not equally.
exactly. Yeah. So they vary in size.
Right. And then you were going to say, are there any documents in the intersection of those 70 subsets?
Yeah.
So if there's any document that appears in all of them, then you say, okay, my new one is actually close to.
Oh no. So a document can only be assigned in one table. Okay, so life's more complicated because actually.
You've done it 70 times.
Yeah. Okay. So forget about multiple tables for the time being, right? So for the single table setup, each document is assigned a single code.
A single 13-bit.
Yes, right, okay. To find all of its nearest neighbours, you consult all of these ones, and then do set operations that you described to find out, the set of documents that are actually potential near neighbours.
So I'm sorry. Does the one table setup that you're still talking about?
Multiple tables.
So how's that set up here? So you're going to iterate over all of the things all the trees with the same hash code. And you're going to run some more expensive test on
Yes.
which looks at the actual distance.
Yes, which does the exact sort of cosine distance.
And maybe does some filtering on when this is
Yeah.
really.
Yeah.
Okay. And if it turns out that there isn't anything that's close, then you say it's a new story. Is that right?
Yes.
But in order to really say it's a new story, there can't be anything close in any of the 70 tables.
Correct. Because it's the same document set, right? It's just sliced and diced in different ways. Okay. So these sort of quality improvement strategies. Okay. Let's go on to them. Okay. So here are the data. Okay. So the experiments I'm now going to talk about, we used quite a lot of stuff. So for Twitter, we used 77 days worth of posts. For Newswire, we same sort of thing. Now, okay. So we use Wikipedia as a stream of data. So this will be new to people. So Wikipedia publish per hour page requests. So every time you search for, say, Baltimore, and I search for Baltimore, say Sandy searched Baltimore at 10 o'clock, I search for Baltimore at, say, 10 past 10, that would be, Baltimore will have 2 hits. And Wikipedia published these statistics per hour, and we have months of this data, right? So hence, that's why you have 18.5 billion of these distinct per hour readings. A lot of these things. Okay. Okay, so the deferral. Okay, so within Twitter, it's natural to think, well, if something of genuine interest occurs, then it will catch people's imagination and people might post about it very quickly afterwards. So genuine events, so this is the sort of citizen journalism business, and genuine events tend to attract comments and retweets and stuff like this. So it's very straightforward here. We run the FSD system, and instead of immediately making a decision, we wait, and then we wait to see if there are any follow-up posts for this. Okay, so as you might expect, the longer you defer, the longer you wait, the more false positives are knocked out. And so here are some. By the way, so if you care about numbers, the numbers are in the papers we published. So I've suppressed all the evaluation. But here you can see it looks better. Instead of having like less than 1% precision, now we get something that's slightly higher. So spam. We still see spam. We see we see Amy Winehouse sort of when she died. We discover this. I don't know what the number 3. Some US thing, number 3. I don't know what it is. and so on. Okay, so this is a cheap way to boost the quality, but you still have spam there. Okay. Mm-hmm. Oh.
So if you had a 1 minute email, would that be, is that the scale that you're talking about? Or are you talking about 5 seconds?
Okay. Okay. So if I just had Hadoop and I had enough tweets to process, then on average I could still get from end to end, if I wanted to process, say, I don't know, if I didn't mind waiting, I could use Hadoop to process my 1 million tweets in about 20 minutes or so, give or take, right? And then the results will all come out straight away. The thing about Storm is that you get results incrementally and as soon as the data goes in, basically.
Well, we understand that if you batched every minute worth of tweets, and each one of them was a run through
right.
each minute, just when you say
yeah.
5 seconds, before a minute.
Okay, so if you batched up the data and run Hadoop over it, then you wouldn't know how long it would take, right? Because Hadoop makes no real-time type claims at all, right? Because it depends on things like what else is happening on the machines, whether disks fail and so on and so forth. But if you truly wanted to just use Hadoop, right, then you'd have to do this at massive scale and not at the moderate scale that we're working at to try to average out over the the overheads that Hadoop has with respect to time. Okay. Okay. So now this is one of my favorite parts is the yes.
So do you draw events from your stored cluster kind of thing?
Excellent comment there. So because we try to achieve constant time and constant space, we need to drop stuff, right? Because otherwise things will get very bad. So we actually have an eviction strategy where posts that are too old just get dropped.
So each point in your stored set
Yes.
of events
Yes.
has a timestamp.
Has-
It goes through the entire thing.
Yeah. So we try to do things like try to maximize the number of these. You can think of these where LS8 divides the space up into cells. We try to make sure there are as many cells active as possible as well. So you visit a cell, eliminate the oldest document, this kind of thing.
Okay.
Yeah. So I realise the time's going, so I need to start speeding up, right? Because unless we could be here for a long time. Okay. Right. Okay. So this is so now on to using Wikipedia. So it turns out that people visit Wikipedia when things happen in the world, right? So here I have two curves. The top one is a curve of Amy Winehouse for a few months over 2011. The big spike is when she died. The lesser spike is some other sort of activity. I can't remember what it was, like a tour council or something like this. So there are these sort of spikes when things happen. And as a control, the bottom curve shows people visiting Glasgow, and presumably nothing ever happens in Glasgow, right? That's why it's very flat. Okay. Oh, it's. I think it's even flatter. Yeah. So this is one of these little in-jokes, because we're doing this for the Glasgow people as well. Okay. So how can you exploit this? Okay. So we run the FSC system over Twitter. We align our discovered events with Wikipedia page views, and we try to find these rising spikes in Wikipedia. If there is a rising spike, then that's evidence that the tweet you're looking at is a genuine tweet. Okay, so that's what So as an aside, one of the nice things about doing social media research is you can have these sort of jokey type titles. So instead of being some hardcore type thing, you can have things like So there you go, sort of my friend getting annihilated, right? So you can have titles like this. Now there are many ways to do anomaly detection in time series, and we just use the simplest one I could possibly imagine, which is just this. Right. So so you process each page request sequentially, and if it looks like an outlier with respect to ones you've seen already, so in other words, more than 70 standard deviations away, you raise your hand up and say, yes, this is potentially an outlier. Right. So it's a rising spike. So that's very fast. Okay. So this works pretty well actually to do this, and here are some more sample results. So almost all of the spam which you saw beforehand disappears because people do not search for spam on Wikipedia, basically. Obvious stuff, right? So people do like searching for sports things and so on. And then again, Amy Winehouse example is still there. Now, the devil is always in the detail, and unfortunately, on average, Wikipedia has a 90-minute latency with respect to Twitter. Right, so which kills it for the real-time event detection. Now, it doesn't mean that Wikipedia is useless, because, for example, you could use Wikipedia to do something to filter out discovered events if you're doing some kind of historical analysis. It's also possible to use this as a cheap way to do labeling for some kind of supervised machine learning activity. The final thing is you could also invert this and use Twitter to predict when people will be searching for things in Wikipedia in the future. Right. So it's not, there are many uses of Wikipedia for Twitter, but event detection is probably not the main one. Okay. And you can also repeat it with Newswire, which does the obvious thing. Okay, so here, these are actual tweets when you intersect discovered events in Twitter with Newswire. So these are beautiful, these things, right? They're extremely clean and so on. So what is the downside here? There's a downside to everything. The downside here is exactly. Right, so the downside here is that if you have Newswire already, why do you need to do event detection? Okay. Okay, so here's some quick bonus stuff. So another sort of strategy, and this is what I did before I came to Hopkins. Another strategy, well, why don't you just sort of train up a classifier? Okay. So I manually labeled 145,000 discovered events, whether they had content or not. So, for example, the top one there had no content, the bottom one has content. And I trained up a classifier, this sort of thing. So the baseline for this task is about 96%. So 96% of discovered events are just not interesting. Right? So you always predict the majority of classes what you get. But with this classifier, we eliminate almost all of the ones you don't care about, and we get about half, roughly speaking, of ones you do care about. So this is probably the way forwards.
Is it using unigrams?
Oh yeah, unigrams and bigrams.
Bigrams.
Yeah. Okay, so here are some examples. So it works. Actually, so this is from September 2013. So these are the actual sort of events that this thing pops out. So it's simply doing the right thing, right? So this is nice in the sense there's no latency at all. So you can use it straight away. Okay, so I will need to speed up, right? So Twitter versus Newswire. Okay. So within the social media sort of world, there is this agenda which says that social media is basically the way to deal with breaking news, and there's lots of stuff out there which breaks first in Twitter and is reported later in Newswire, right? And obviously journalists feel threatened by this because it's undermining their job, right? Now, whenever people talk about this, people always use the same examples. So people always talk about the Hudson plane crash and earthquakes, right? And there's this sort of extrapolation that all breaking news is somehow going to appear first in Twitter. So we looked at the question of how general is this claim. Right. Okay, so what we did was we identified 27 actual things that happened in the world. So these are not events we look into Twitter or into Newswire, things like plane crash. I'll give you a list of these things, like 27 of these events. And the task for us was to manually find when these things first appeared in either Newswire or Twitter, and then do a comparison. And this is, well, that's the paper. By the way, when we did this, Edinburgh put out a press release about this thing, and journalists love this stuff, as you might imagine, right? Because as you'll discover, what this says is basically they're not out for a job. But there was also a very different reaction in Twitter itself, where people think, no, how can this be? So,
which reaction came first?
Yeah, journalists came first. Yeah. Okay, so here are some events, right? So these are the actual events, right? So these are not tweets. These are just these are like topics, if you know what these things are. So time in Newswire, time in Twitter, and then the lag, and so on, right? So there are 20. I'll skip through these fairly quickly. So there's one of them. By the way, so does anyone know why there's a massive lag here? If anyone knows anything about languages, have a guess.
Are you looking in the English Twitter?
Exactly, right? So this was not reported in English, and it took time for it to go into German, then to English, right? So that's why you see this big lag. Okay. And then more of them. Okay. And more of them. Okay. So this one here is an interesting example. This ferry sinking. Because if I remember correctly, the ferry sinking problem only occurred a few times in our data, but we still picked it up. So there's an alternate strategy of doing event detection, which is looking for spikes in terms, and that would not happen here. Okay, so what you can see here is that it's not obvious. So it's not that Twitter is uniformly sort of leading Newswire or vice versa. Right? It's kind of mixed. Okay, so there's no evidence basically that Twitter generally leads for breaking news. And on average, most important news is first reported in Newswire. Twitter tends to repost stuff which is already out there. And as I said, most important stuff appears in Twitter as well. Now, yes. Okay. So then you can look at various classes, right? So when does Twitter lead? So so things like earthquakes are pretty in public, right? Yeah. So Twitter does lead, tend to lead for earthquakes, fires, and stuff. Sport, so you're on the stadium, you know, my team has won, kind of thing. But to my mind, the interesting class of things where Twitter does lead are these hyper-local events. So events that only matter to me and not to Sanjeev, right, if that's possible. Stuff like this, right? So for really long tail type Newswire events, this is where the Twitter does lead. Okay, so here are some, which one is this one? Okay, so Newswire reports stuff not in Twitter. I love this one. So presumably people in social media don't think that's important. Okay, so that's that. And Twitter breaking news not in Newswire. Right? So here, as I said, it has this more sort of localized feel to it. So you've got this sort of car. That's the police one I gave example. I don't know why the NASA one is like this and so on. But you can see it has a different feel to it, the kind of news which is in Twitter but not in Newswire. Okay, comments? Okay. So now I'm going to wrap up on the hour. Pretty good. So, yes. So these experiments would not be possible without taking the engineering seriously. Right? So without, actually it's mainly LSH, not so much Storm, but without LSH, it would be almost, I reckon it would be impossible to do these large-scale experiments with Twitter and sort of get results. There are a variety of strategies of trying to boost the quality. I think that actually sort of manually labeling data is probably the way forwards. But it's not the only way. There are interesting relationships between Twitter as a news service and Newswire as a news service and so on. And the experiments here sort of help you to get more sort of insight into what's happening. I suspect that Twitter is probably most useful, as I said, for hyperlocal events, disasters and sports and stuff like this. Okay, so what's next? Okay, so unfortunately you have me for a year. so I've got plenty of time to sort of waste on this kind of stuff. So we are actually working on the problem of trying to efficiently integrate geolocation into the hashing task. Right? We're doing this. You can imagine things like personalization and so on. So the stuff I care about isn't necessarily the stuff that Jason cares about, this kind of thing. There's a very open problem of trust here. So we've done absolutely nothing with the events that we discover, and we take them all at face value. And there are a variety of sort of downstream applications you might imagine. Okay, so we have released lots and lots of data. So we have released tweets with relevant judgments, whether they are relevant to the 27 topics or not. And there's lots of reading that you can, if you want to follow up on this stuff. Okay, right, that's me done. On the hour, almost.
So I have two questions. First of all, I was curious if you looked at different vector representations for the tweets, because one issue obviously is someone might talk about bombing versus supporting something else, and there would be wood, whatever else. So you could use different embeddings like LPA or like learning. And I was curious if you tried those and if you found some to work better.
Okay, so the first question was basically, might there be different dot representations for this, right? And the second one, have you looked at that?
Actually, the second one I asked you guys.
So basically, this is a straight up IR type task, and people looked at all sorts of ways of representing documents. We've done nothing. So it's a chance for you to sort of get some new work on that. One thing to bear in mind is that it needs to work at scale. Right? Yeah. So because we use this hashing approach, it needs to be consistent with the way that hashing works. So in particular, if you came up with some alternate, say, if you use some alternate retrieval model, if you can't construct some kind of way to find posts using hashing, then you're doomed. So that's the problem. That doesn't mean it's not possible, right? But yes, it's hard.
And the second question I was told to ask you, adding more pictures of your channels.
Oh, good. I got plenty of what is that? I actually have lots and lots of cats.
Have you looked at the percentage of breaking news tweets that were not from these breaking news?
Oh, that.
Yeah, right. Like how many are from a non-news entity?
Okay. So we don't have any actual numbers, right? But anecdotally, so I've looked at lots of data. The vast majority of stuff out there is reported, is published by writers anyway. People, there's actually very little citizen journalism going on. Now that might be that we don't find it, right? But I don't think so.
So in the comparison of Twitter to Newswire, Twitter sort of, so the cases where Newswire led, the lag from Newswire to Twitter seems like it could be misleading if the Twitter people are just pouncing on the Newswire report, right? Did you ever look at those numbers? Like how often were the Twitter tweets just repost, like pointing to the story that somebody had read?
So most, So okay, so for those big tables I had, right? Yeah. So we would, if we saw a tweet which had a URL in it, we would count the URL as first, not the tweet.
But I was thinking of the lag time. So when you calculate a lag time, were those still counted as the?
Yeah. So we would. So trying to do this is extremely difficult. Now, unlike tweets where they get these nice timestamps, web pages, sometimes it's next to impossible to work out what the actual time is. So we had to have a best sort of guess at that kind of thing. So I'm not quite sure the answer.
Twitter is to become the massive news aggregator, then isn't this problem really the point? So in the limit, it should be a tie. Right? I mean, Twitter can only either be at the same. If every journalist is immediately posting to the New York Times and tweeting it simultaneously, then Twitter can only be that. Right? On average.
Yeah.
It's assuming that then all the German newspapers are also
Right. So personally, I don't think that Twitter is useful for breaking news, for major breaking news at all. For problems like this, right? I actually think it's much more useful for these things that never reported, or trying to identify events which will be reported first in Twitter and then picked up. So it's the things so Twitter as a medium, right? And then journalists looking to Twitter to get news, rather than people looking in the outside world to get news and reporting it.
So I realize I'm a little confused about the definition of breaking news in the following sense. So on Sunday...
okay, so let's talk about. I'll give some caveats.
Yes, thanks. We'd all like to serve that. So on Sunday, something happened that was a surprise, namely that Chuck Hagel ordered Defense Department employees back to work. And so I bet your system caught that. But when the government shutdown happened, that wasn't a surprise. It had been in discussion for a long time before that. And if the U.S. government goes into default in a couple of weeks, that won't be a surprise either. And so what does your system do for events like this which are anticipated?
So the question is, what is the story about planned events, right, versus spontaneous events that are out there? As far as we're concerned, there's no difference. So we're still looking. So think about the definition. The definition is something which looks new, with respect to things you've seen already. There's no sort of external agency you can talk to.
Okay, so I think what you're saying is just try the system and see what I get. And it might not discover when the government actually has shut down because its vector representations, to build on Nick's question, weren't rich enough to recognize the difference between present tense and past tense as being important. Or future tense, rather.
This is fancy concept. So in my previous life, when I used to take language seriously, yes, I'm sort of transmuting into an IR person. IR people don't care about tense and stuff like this.
Back there. So this is actually a follow-up to this question. So like if you see that one person has sort of anticipated the government can shut down. Let's say there's some investor like George Soros or Plant Fine says on Twitter or something, the government might shut down. Do you suppose that, and that might not be something that they say on actual newswire, so would that be considered breaking news? Like, insights which knowledgeable people give or about the event, like that will be one way it will be useful, right? That's something which people can't really say on newswire because they are not journalists or they don't own the newspaper, and so would you think that would be one way in which Twitter would be useful in this?
What Twitter be useful for finding things that are
so if people give out knowledge they have about certain events, like in anticipation, can the event detection framework sort of catch that?
Right. Okay. So one sort of shortcoming of the way that we do it, and is that there is this assumption that one post captures the event. If there is some sort of event which is fragmented over multiple posts, we wouldn't see it at all.
Is there any special attention paid to hashtags and such, in the sense that with story becomes trending, but certain hashtags catch on, or is it the time scale when you catch on longer than your preferred?
Okay, so that's a good question. So the question is, how do hashtags basically relate to the event detection business? So when people first start using looking at Twitter, people get very excited about hashtags. You know, it's something new and different, right? On the one hand, the most tweets don't actually have hashtags attached to them, and that's probably also true for events as well. People use hashtags in very inconsistent ways. So we saw some examples just now of you saw things like the hashtag and then some sort of like jokey commenting, right? So hashtags themselves are of mixed value, but as far as we're concerned, a hashtag is just a term. So we don't have any special treatment of hashtags. Now, you can imagine possibly doing something which, say, promotes them. It's kind of saying, you know, this is a term which is a some sort of hashtag that somehow boosts the importance of it.
So it would still get incorporated into the hashtag function.
Yeah, it would just look like another word.
So I have a general question about the way you posed the whole problem. So when people were working on this first story detection, there was this notion that if you lay the stories out along some time axis, that then you can take any one story and thread it with all the other stories all the other documents that are about the same story as this document is about. And now you have this set of documents which are threaded together, and you want now to find the head of every thread. Right? But to do that, they really had to look at the whole collection of documents and more or less exhaustively decide for each document which thread it belongs to. And of course, a bunch of documents are one-off, they don't belong to any thread, but by definition, they're themselves first stories on whatever they're about. Right? To really evaluate what you're doing with Twitter in a sort of similar way, somebody would have to look at all these posts. So I got the feeling that you did something that was kind of close enough, but not really. So what is your feeling about that?
So how did we do evaluation, or how should we do evaluation?
How did you do it, and how would you rather have done it if you had more resources?
It's actually not a resource thing. So what we actually did was so there are, roughly speaking, so the problem here is trying to measure recall. Right? Because on one hand, there are things you're looking for. So there's 27 events, right? We can find them. On the other hand, there are things you didn't anticipate which are also in the data. What we did. So behind all those anecdotal examples were basic precision and recall type ones. We manually labeled data.
Very good.
Now the way that sort of evaluation works in the IR world is to do pooling. You know about this business. Yeah. So our current thinking is to do more pooling type evaluation. So because it's just us, what this means is running our system again, getting the same data, looking at the new things that are proposed, manually labeling them, then adding those set of labeled documents. Then you can imagine this something converging and then doing some automatic step. So that's what we're doing right now.